actually it's 0.8, so let's make it 10 even, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That looks pretty good. 20.
Right. We hit our first harmonic, and in increment of 1 hertz.
25, 27, 28, 29, 30, not much. 31, 32, 33, 34, 35, 36, 37, 38, 39, 42.
Great.
42 is pretty good. 41 is all right too. 42, 42, 43, 44, 51. We're starting to see something. 62, pretty good.
Good.
All right, we'll try 83. We should also try one where it's not, it's off. So let's see. So this is 83, and that's pretty close. $82.5, 82.1. So that looks good. 82.7, 82.6, something like that, right?
Right.
So you got 1, 2, 3, 4 antinodes. 1, 2, 3 nodes in the middle, 1 node at the top, 1 node at the bottom. All right, now so the next one up in the series would be 5 times 20, which would be 100.
So theoretically, it should be integer multiple.
It should be an integer multiple of
The
fundamental.
fundamental, right. But we have our uncertainty error coming from the vibrating.
Well, I think the problem is that this isn't quite a node.
Right.
This is, the node is down there, and the position of the node changes a little bit. So
How about the string quality, the stretching?
Yeah, the string is the speed of so the frequency times the wavelength gives you the speed of the wave on the string, not the speed of sound, but the speed of the wave traveling on the spring.
Right.
Which we'll look at in a minute with the slinky. And so the speed of the wave on the string is not quite constant. So the speed of sound in air is pretty constant, independent. I mean, it changes with temperature and things like that, but pretty much independent of the frequency, but the speed of the wave on the string is a little bit frequency dependent. So it's not perfect, but anyway, and this is an anharmonic effect, and that happens in instruments, real instruments too. So, but not quite as bad as this in the real violin or cello or something. The string, the harmonics would be much closer to the whole number multiples. All right, so the next whole number up would be about 100.
I think that's the close we can get.
102.7. Yeah, how about 102.8? So here you got 1, 2, 3, 4, 5 antinodes. 1, 2, 3, 4 nodes in the middle. 1 at the bottom, 1 at the top.
So this is our fifth harmonic.
That's fifth harmonic. Yeah, so you can tell by the number of antinodes.
Yes, these numbers, we control our frequency and amplitude of the wave, of the signal that we pass it to the vibrator. 123.8 hertz right now. And
so now we have, there's supposed to be 6 antinodes. 1, 2, 3, 4, 5, 6, sure enough. And then 1, 2, 3, 4, 5 nodes. And 1 node at the bottom and 1 node at the top. Well, so 120 should be 6 6 antinodes. 1, 2, 3, 4, 5, 6 antinodes. 1, 2, 3, 4, 5 notes. Here's something. 144.
We have 7 antinodes.
1, 2, 3, 4, 5, 6, 7.
Right.
1, 2, 3, 4, 5, 6 notes. 1 at the bottom, 1 at the top. And 160. You're starting to hear it now.
Yeah.
160 hertz. I guess you can hear pretty well, huh?
The scope reading is good. Wow.
Oh,
That's 180?
no, that's 160. That's
Oh.
159.
59.
159. So that's 160 is 8 times. So should that 8 antinodes. 1, 2, 3, 4, 5, 6, 8. And then if I go up to 180,
That's the 9th harmonic.
no, not much. I think we lost them.
Or tweak around with 0.1
Yeah,
frequency.
I don't think it's gonna matter. I think it's gone. I think we lost the capacity. The machine can't do much. It's not vibrating much.